I'm Kuo-Yi from National Kaohsiung University of Science and Technology. My topic is the smart manufacturing with data imbalance for diagnosis. The first is the introduction. The introduction is regarding to the problem definition of the problem, because in the for diagnosis of the hard drive is very important to maintain the usability and the quality of the product. But actually, when we got the production, we only collect some data from the manufacturing production line, and the manufacturing production line will force a problem about the data imbalance, because most of the data is very good, but we focus on the problem with that for some low quality products, and we want to know the reason and the cause, how to find it. Also, if we find the problem, also it's always delayed for the factory, and also we will cause the stop or for the factory line, or have some part of the manufacturing line will stop. In terms of the usability of the maintenance, we will waste a lot of time to find the expectation of the machines. So this problem is very important. We need to do the further results for the smart manufacturing. Also, machine learning for the equipment downtime is also very important when we started to the new industry like the industry 4.0, and we need to better understand the equipment, the sensor, and the capabilities. And also we need to find lots of the number of machines, and to find the relationship of the root cause why will make the problem. And we need to find a better time to design the maintenance. So in the overview of the introduction, we will know there are a lot of problems we need to focus on. And the research arms is to build a deep learning model to predict maintenance for hard drive equipment downtime. And we need to find deal with the imbalanced data, and to find which is better practice for the data and the sensoring, and to find the logs. And in terms of machine level and the component level, will become the different challenge for us. So we need to find a better practice for that. So recently, because the remain results and to the trend of the like the smart manufacturing, for terms of digital manufacturing also is very important, and we need to find the editor-in-chief, like the 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 JIM, Journal of Intelligent Manufacturing, and we focus on the digital manufacturing, like to find a better practice for transform the problem to make it better. So like for this is just for you as a remark for results. Also, we need to find how to deal with that. And the first, we will give you some background for how to deal with this problem by machine learning. And the machine learning will usually to transform the data with the training and the testing, because the training data was to build the like the expectation results, also construct the model to inspect how to deal with the problem. And we usually do is the function to know the function with the unknown, and to define the loss from the training data. For our result, we need to find the root cause of the relationship between the data. We need to find how to deal with this. And also in the model, we need to do the optimization for that, and to make it easier, and to make the better practice for that. And also we need to another part of the testing data. The testing data is to test the results of our model, and that will become the best result for the testing data. And the testing data just like this one. So the training and the testing data combined will become most of our real data. Also, sometimes we need to validation data to have a better results to check the model and for better validation. So we need to find the results to better understand that. We need to the usually general guide is that we need to find when every time we train the data, we will get the loss of the training data, and then it will become, if the problem becomes larger, we need to find the model bias, and to make the optimization for that. And also for the testing data, we will calculate the loss of the testing data, and to find is the result is good, or it's overfitting, or sometimes with a mismatch. So as a result, we can find the better model to deal with the for the further prediction, and for the diagnosis. So this is the expectation we need to do the model. And the imbalanced data is sometimes because we will focus on the few but very important issue. Just like for the manufacturing, we usually focus on why is cause the low year. Just like to find the reason what will make us to generate and product the product with not good quality, and that will be easy to understand what the year means. So based on the trade-off, we need to find how to deal with the data. With the bigger and smaller data, we can deal with that and to find the better results. So based on the data we are doing here is usually sometimes we'll say is data science. So you can try to know we will better understand what is the model bias. The model, sometimes if the model is too simple, and we will find the different kind of way to get the find the frontier of the data results. And if we can find a better description of this kind of data, that will mean like usually we can like the R-square, and to understand what kind of the data we will use to better describe the model, and to have the better loss. Is the usually means the small loss. And with this solution, there's no need to have a haystack, but we can have make it more flexible. So the way to do the more flexible is that we can find the feature to describe it. Just like for this is the we sometimes know is the regression model, and it's easy to understand. Also, if we need to have a better result, we sometimes use neural network, and then we can have the sigmoid model and to better describe it. In the age of the artificial intelligence, AI will become more application as we used it before, and like the deep learning result, machine learning results will in fact a lot of real situation and to some results for us. So just like for everywhere, you can see that just like when recently we are using a generate AI like a GPT, you can have better communicate with that and to know what it can do and what it can deal with, then to do some support for your work. Also, if we need to find better results in this situation, we need to have the trade-off between this kind of data, and that will be better to know how to make the optimization model for us. So it's quite easy for the summary of the why we need to use machine learning for a framework like that. We can use to find the optimization of the data, and that means when what kind of design of the data we can deal with that and to have it better results. So based on this result, we need to use find the large point, and to find this means the smaller lows of the function. Like for example, sometimes we use classification. Classification is we try to find some rule, find to some rule to divide the data with the different group. That will be better. So just like classification, just like we can use some just like data to classify your classmates with sometimes or hobbies, or sometimes you can calculate with different kind of the rules and for some parameter, and we can have the different results. Also, we need to find the data and the rule to better describe what's the results, and to describe the model for the data we collected. So we need to find when we doing the model bias. Then the model bias is sometimes we got all of data, and the data will become bigger and bigger. Most of the data we focus on is the regular data, just like if we need to find the problem results, we need to focus with more data, like the production just like have some troubles to find the results of the year with a lower year will be better for us. So we need to find when we deal with the optimization issue, we can better deal with that. So this is why we focus on the imbalanced data, because we don't want to know the problem like we make a good product. We want to know what's the reason we have the trouble with the product is not good. That's easy to get it. So we need to focus on that, and to build our model to find this issue. So we sometimes have to compare with some results, just like the gain insights from the comparison for different kind of models, like the if we build a model with 56 layer compare with 20 layer, and we need to find which is better for our description. So sometimes we will check the ROC curve and to find the error. So for the error, we need to know which the error will become lower, and the last will be the results for the optimization issue for us. So for the optimization, we need to gain the insight from the comparison. So we will start from slower network, and which are easier to optimize. And if we got the same level of the optimization level, in the real case, we will focus on the easier to find the results will be better for us. So if the deeper networks do not obtain smaller loads on the training data, then there's optimization issue. Just like we can compare with different kind of layers and in different time, that will be better for us. So as a solution, we will find a more powerful optimization technology to find the results. So when we try out the model and the bias of the overfitting, we need to find the data with the set of validation set for model selection. And for the small conditions, like the losses and testing data, if the is smaller, then that means that's good. If it's larger, and we need to deal with the overfitting or maybe some situation with a mismatch. So that's when we deal with the overfitting, we need to better understand it, because the overfitting is when sometimes we do training too much times, and our model will be more fit with the training data, but it's far from real case. So we need to to find the extreme, just like the extreme example for training data. We do it with all kind of situation with the training data, but actually it's not fit the real data situation for that. So we will less than use this, and the function obtains zero training loss, but the large testing loss will usually happen when we deal with the overfitting problem. So for the overfitting problem, the real data description is just like this one, and for the training data. But the flexible model, if we doing much overfitting, then the data we not calculate that with not support for the model, then this means the freestyle for that. And if we get more testing data, and we will see if this model will more fit with our data. So if we use this like the overfitting model, we use testing data to compare the results. We will see there will become a large loss in testing data, but it's very fit as the training data. So that means the overfitting. So if we got more training data, and we can have to find different kind of results, and to better fit, just like we need to classify the cat. Like we want to diagnose one kind of problem, and we can see everywhere every kind of situation of the data, and we can do this one. So for the overfitting, if the data we with the different very curious results, then that will become this the loss parameter, and we need to share the parameter to find the full connect with the CNN. So if the overfitting will become too much, then the data is the data was far from real results, then that's also not good for us. So we need to back to the model bias. And the bias competition trade-off. So for the real case, we use the loss function to think about what's the training and the testing. Also, we need to find the trade-off the training and the testing, because in real case, because we use training data to train the model, if we train it more several times, the model will become more complicated, and the complicated result will not good for testing data. Just like we're in the beginning, we're talking about the training and the testing data is all the real data we divided with different situations. So the training and the testing, that will become we recalculate and to find the results. So then the second part is the self-supervised learning framework. Self-supervised learning framework is like if we have the data, and we use this data to have the training result, like the self-supervised, and we are learning by text but not required label data, because this is self-supervised. Then we will have the different kind of model with different case text, and we have the downstream text. That means autoencoder. And the autoencoder is have lots of implications in machine learning, so it's better for you to know what this autoencoder's meaning with the compare with other kind of the data. So the autoencoder is like if we have some figure, and that is the objective, we need to find it, like the different kind of the pattern of the data or some image. We can have the first is neural net encoder, then we will divide it with the vector. With a lot of the unlabeled image, we need to find it, and we use the encoder with, and the length we focus on the vectors that will become the better decoder, and we will have some image the relationship with this data. Then with this model processor, we want to find the coding result will as close as possible. Then this is the reconstruction, and with this one we can have the same idea with like the game and embedding representation and some code, and with this new feature we can have some characteristics, just like some key terms to find the image we need this, and that will become the high dimension and the low dimension. We can have the hot bottleneck, and to find what's the key result for us to the results. And we use the as close to check the as close as much possible, then we can have some pattern, just like we will focus on the pixel for the each image, and this image will deal with that, and to mapping the result. That will easy for computer to identify what kind of the pattern in the data. Also, in the data, we can calculate the results with the different imaging, or like the data sequence. And this sequence will become the result we need to find it. So this is called the pattern. And this data, this uh, algorithm will, like the autoencoder, to reduce the dimension of the data with the neural networks. We published it in Science from 2006, and this is very high recommended technology. Recently, we used it to find the result for the fine. So for this autoencoder, the concept we are introducing, and also they have some different results, and I will just show you to as our background knowledge to deal with this. So also we need to find the pattern as close as possible, and to find these results, and that will be easier for us to get the identify that. The idea sounds familiar, and like this one, like the bird. Okay, the bird is the to do noise encoder, embedding decoder, and to do the reconstruction. So based on this, the tree as an embedding will become the just like the generator model, and also to find the sensing order, and do it as a result. And based on this background introduction, we can back to our data, like our topic with researchers in different area. For the artificial intelligence will deal with the imbalanced data. We can see there was a lot of different kind of area, like the computer science, mathematics, engineering, automation, control system, or managing area. There's a lot of area we'll consider we deal with different kind of problem, and for this problem we are for most different area will consider it as well. So how to deal with that? Because we know the training and testing data already, then we will introduce another issue about if we deal with the imbalanced data, we need to find some way to solve the problem, because the imbalanced data will will inflect our model to focus on the most of the data, and the most of data in the yield results, like the small magnification we focus on. We most of time we focus on the problem with how what's the root cause will make the bad product. Bad product, that means the product with low yield, and the low yield will focus on become a big issue if we we are not focus on that, then will become a bigger issue with the yield of the production line will become lower and lower if we not focus on it. So we need to find the like the different kind of class, we need to indicate the distance of the sampling, and to find the set what is the better close to the area. So according to the proportion of the sample, we need to find the sampling proportion to determine the sample multiplier for each sample. Then latter is the better reputation for the data. So this is the oversampling we focus on to try to balance our data and to find what's this more important like the results of the data. So then we use the autoencoder, and the autoencoder as summaries we have know is a type of neural network, and we focus on the data with the different with the first is encoder and the decoder, and we have the find the how to deal with this and try to find the reputation, and the real case was much closer. And also we use the co-sensitive model and so mix layer to find the model and to find the different algorithm and to find the different losses. As the softness layer, we estimate the probability of the occurrence of each category, because we have mentioned that in different kind of cases, we need to try to balance it and to find the better category. In real case, for the smart manufacturing, we need to identify what kind of category, what kind of the problem we focus on, just like the fault, what kind of fault. Usually we will not consider every kind of the fault. Sometimes we need to focus on the most important, like the rule of the 80-20, and what is the more important and like the better sequence of the problem we need to focus on. So the softmax function formulation and also the function we will build up as our key results, because we will also consider the time, like for different kind of algorithm. So that is the problem we deal with, and then we have some design for the results. Also, the full diagnosis of the framework of like the hard drive, we got the four phases. The first phases is the problem definition. We will try to find the key result why it will make for the downtime, and we focus on what kind of model number and to find the better feature. And the feature we need to find which is the influence the working time, and which have a more impact for our production line will become more important. Then the second is the data preparation. Data preparation usually will take most of the time, like 70 to 90 time, 70 to 90% of the time we deal with to solve some problem. Like so the data preparation will cost a lot of the time to do with this. Like we will have the dimensions of the different kind of time, and to find the features, and to generate the model, and to have the data with the training and testing. Also, in the different kind of issue, we have some like the smart and the autoencoder to deal with this. And the model construction, we will have the data refactoring and to deal with the class balance and the feature extraction. Then we will deal with the neural network and to find the results. What's the key terms will affect the result of the evaluation model and the comparison and analysis. And in terms of data refactoring, we focus on the create the data features and to generate the model dimension, because in our systems we will not deal with the problem by it need take some time to find the model and to find a pattern. So we use the runtime and to deal with for time to time and to have a better model prediction. Also, we can have a different result for that. Then we focus on the class balance and feature extraction. For the data set, we use the divided data set by the category, because there are some category and there's some issue from in our data, and we need to have the data with the divided by different kind of category, and to clean the data with the better what kind of category we are easy to get it, and is there some missing data, and the missing data we need to deal with that. Then we divide the data with training data and the testing data set. And to shift the two training and testing data into the data sets with a rolling machine to have the results. Also, we use the SMOT to use the generate a new sample for the training data set, and to the focal loss we impose the pointing factor, and we use the autoencoder algorithm to find the optimization algorithm as a result. And then we use the classifier to adopt the SDG algorithm to find what kind of the data will become the root cause of the R function. Also, we combination of the co-sensitive and the model with the SMOT to focus on the real. So like do the comparison with different kind of layer, and what is the input and output and the activation, and to compare with a different kind of type, and then we can have the better results to find the prediction results, and to calculate what is the better, and to deal with the real cases. And also we use the results and the implication for our in terms of we use the model to training our results. Then we can have some classification results for each type, and then for this type we use the time window to find the results, and like this means bags. And the bags is if we have the prediction result, we use the prediction result to modify the future words, but the system is keep rolling, so we cannot use it training to change the recipe or the machine situation real time. We cannot do it. We need to do it to compensate it from time to time. That will means why we use bags to do it for the practice. So as a result, we can find the very hard type and to get the serial number to check it, and then we have serial number and the corresponding time and point, and try to fix it to just avoid the break time, and to find a better interfact window that during this window then we can use. And the break time will not happen suddenly, but if the break time have size which mean and the hard drive, we need to try to fix it as much as we can. So we use the back the results 7, like for example we use 7 back. Also we can in different situation we can use 4 back or even more 20 backs, and that will to have the time point to deal with this. And then we can have the further way to make the stable for the production situations, because the production situation, if we have them, can you become more smoothly, then that will save a lot of the time and the money when we get a production. So this is very important for the real practice. Also, if we need to do some maintenance, because the maintenance is very important when we deal with some real-time machine manufacturing, then we can use our model to give the guideline for smart manufacturing, and to find the results, and to better enhance the yield of the production line. Also, we need to know the prediction yield of the from time to time products. So based on our model, we can easily to predict the result for that. So this is the model construction of our results. So the empirical study, we focus on the model and serial number, and the two ceremonial analysis and the report technology actually is for the hard drive data especially is collect. So we represent raw and normalized values, and this is the data we collect. And we can see in some category layers have no data, because for some situations sometimes the data will not need to make some more record or have some mark. So it's usually will happen when we in the real case the data. Then the mission value, we will do with this to discuss with the domain experts, and then we to find which is important, and for which data we need to do some fill the data, also how we combine the data. Then the data preparations, we focus on the equipment variables to under representation in the dataset, and for the missing value, which needs to missing value processes, and we have more than 120 features. Also, for the missing value process, we will deal with that to remove the feature with more than 1/3 missing value, and fill the missing value with the average of nearby data for each model and serial number. And we will do it based on the discussion with the domain experts to do not bias the result of our analysis. Then experiments, we use by our code, and we have the model system to deal with that. And then based on this, we can do the data collection and the feature and engineering. Also, we use the modeling and all the system we were created by ourselves, and to customize the results and to use this to the result. Also, the classes where classes we decide and define it is based on discussion with domain experts, and to find the results and to make it more reasonable, and to do not make more other better results, to have the real case situation analysis, and also to deal with the results of the empirical studies and the problem. Also, the experts we are focused on to find a balanced focal loss, and the results as this shows will become we have more impact than the old model, and that means that our results have the better accuracy and the precision and recalls. The reason, because the first is we do the results with the very real time, and to make focus on the problem, so we can build data without like the oversampling, or like without the overfitting results. So we can have, that's why we can have the better accuracy of the result and the precision. And the precision, because that's the huge gap between the precision is because in this case, and in the usual cases, most of the like the full diagnosis results will not focus on the trouble data with the some data with the row years. Will not only focus that. So that's why the old model is very bad for the precision, because there's more and more data, less is good products. Okay, so that is why there's a huge gap between the precision, and the recall is much more important in this case, because the recall means the product is not good, and we can better to identify all the bad products. That will be more important, because in old model, if the recall is not so good, that means sometimes if we the manufacturing system, if we are not produce a good product, that means the product is bad, but we think this one is no problem, then that will become a big problem with that, because we think this is a good product, and we to send it to our customer, and our customer will affect the quality based on this one. So in this case, the recall is more important here. Also, the compare with SVM with oversampling, we can find our result is the loss will a little bit smaller, and the accuracy will become higher for the results. So this is the results compared with other methodology. And the predicted number with different kind of the bag. And the bag will easy to affect the result of how to do it to different kind of the comparison with that. And that is very important. And the conclusion, okay. For the small than neural network model with a backend deep learning will become the highlight of this research. And also in different kind of situation, we are not always focused on the same, because we need to focus on the problem with the different kind of the methodology, because in the machine learning we have more and more new methodology every day. So the very important part is the first is you can always find a better methodology to solve the problem. Also, the second is for the deal with the empirical with some domain experts, you can easily to get how to solve the problem with more ideal results. And the third is the early warning function is very important for the tool health. If we can save more time about the tool, like the machine, and the machine will can do more manufacturing or do more production every time, and then that will better to have us to result to make more impact. So they will save the hundred of money, like some millions, and to or even more in every periods. Also, we need to, based on the data and based on our problem, we can solve it, and to find what kind of the issue we focus on is very important, with the different kind of the inference point, and to identify different kind of the health of different situations, and we can indicate that the different aggregation at different kind of results, and to do the recovery for each time is very important, and to find the results. So as a three conclusion, then the first is some new idea is usually to face on real problem as our situation will become more complex. So we are not focused on one, like the machine learning methodology to deal with every kind of problem. That is not feasible. Sometimes we need to focus on the real case, and to have a different kind of methodology to fix it. And the third is what's the impact to empirical study was more important in this area to make us to succeed to the smart manufacturing. Smart manufacturing is more important. Okay, then this is the reference of these results. If you have some question, feel free to let me know, and thank you very much for your attention, and looking forward to see you soon. Thank you.